Hey everybody, this is Larry. This is day 21st of the June Leetcode Daily Challenge. Let's get started. Hit the like button, hit the subscribe button. Let me know what you think. Join the Discord for a chat and dungeon game. The demons had captured the Princess P and imprisoned her in the bottom right corner of a dungeon. The dungeon consists of M times N rooms laid out in a 2D grid. Our knight was initially positioned in the top left room and must fight his way through the dungeon to rescue the princess. The knight has an initial health point represented by a positive integer. If at any point his health point drops to 0 or below, he dies immediately. Some of the rooms are guarded by demons, so the knight loses health upon entering these rooms. Other rooms are either 0 or contain magic orbs that increases the knight's health, positive integers. In order to reach the princess as quickly as possible, the knight decides to move only rightward or downward in each step. Write a function that determines the knight's minimum initial path so that he's able to rescue the princess. For example, you have this thing. Okay. There's no upper bound, can contain power-ups. I think one thing that I would maybe think about is that well, there's no constraints on the problem, which is a little bit tricky. But I think there are a couple of ways to think about this problem. The way that I don't know if this one's in time, but one way to think about it is that this is dynamic programming. And the question is, well, let's say you start with a health of X health. If you have X health, can you get to the bottom right with more than 0 health along every step of the way, right? And you can do that. That's a very standard dynamic programming. It's not an easy dynamic programming, but it's standard-ish. And if you say, and let's say you are given that, then you're able to do a binary search from that K from 0 to, or I guess not 0, but 1 to some infinite number, and then you just have to run that every time, and that will give you n times m for the dynamic programming times log of k, where k is the range of the possible health. I think, however, though, you can also use just regular dynamic programming, and in that way it's a little bit greedy, but the trick observation to note in this problem, and I think I've done a similar problem in the past where it didn't work out for me, is that one thing that I want to point out is that in a lot of dynamic programming problems, at least the ones that are on Leetcode, you could solve them symmetrically. And what I mean by that is that you're having a matrix or an array, which is a 1D array or 2D matrix. What you mean is that going from top left to bottom right, or going from bottom right to top left, it's symmetric in that you could go either way and it's the same answer. Or if you have a 1D version, going from left to right or right to left. However, in this problem, because of the constraint that you can not drop to 0 or die, then that means that there's a strict ordering, right? And that means that you cannot just go, there has to be an invariant that you hold where the solution at every cell means that you are still alive, right? So based off that knowledge, we should be able to come up with the solution. And okay, so having said all that, let's think about how to do it. Let's just implement it top down. I have a video on dynamic programming that converts top down memorization to bottoms up dynamic programming. Take a look and then we'll figure it out together. But for this one, let's just solve the thing, right? Which is that that's given a calculate, which is from XY, or actually RC for rows and columns. Let's just do rows is equal to the length of the dungeon. Columns is equal to the length of the first elements. And now let's just check that if rows are 0, 0, we return. Actually, it's not clear that we know what we should return, so let's just say 1. If cause 0, 0, return 1. Okay. And then we could return calculate from 0, 0, right? To all the way to whatever. And at each cell, what we want is get the minimum health that you can be on this current cell, right? So what does that mean? Well, base case is if R is equal to rows and wait, now this is -1, cos -1, so this is the base case, and in this base case I guess we have to be at least 6 because you want to end with more than 1, right? So so what is that? So return dungeon of RC. Let's just say so we want the answer to be at least 1 or the negative answer plus 1, right? Because if it's -5, you want it to be negative, you want the answer to be 6. If it's you know, so forth. And the other case is if it's positive. What happens if it's positive? Well, if it's 5, then that's fine. Your health coming in should still be at least 1. So that's what it's referring to. Okay. I think that's okay. And then otherwise, if okay, I think that's the only base case we need, depending on how we do the edge. So yeah, so now we just do so best is equal to, let's say, infinite health. Can we do better than infinite health? Well, if we go to the right, so we go R plus 1, C, but this assumes that if R plus 1 is less than rows, what this gives us the minimum thing. Oh yeah, so actually the best score, there's a lot of cases, so I'm trying to do it really slowly because I'm thinking about it through. But basically, let's say now, I mean, and there's some symmetry here anyway, but so you're going from one cell to another. What does this mean? Well, let's say -5 to 10. Well, the 10 means that the minimum health going in has to be 1. So okay, I'm going to just now have a helper function that gives me the score of a given cell, so that I don't have to keep on. Basically, it's the same logic here, but it allows me to focus on the code a little bit. So it's really tricky to get exactly right, but okay. So now the score that here is that, well, it has to be at least 6, right? So actually this should be the score of the current cell. Oops. And then now, so we have to take one of 2 paths, right? And what is the clean way to do it? Because there's 2 cases, and we want to, okay, but path is equal to 0, and we want to take the case that is the min of the, So we want to take the path that gives us the min, and then we have to check that against best. Okay, so this should be infinity. And then path is equal to the min of path and calculate r plus 1 c. And if c plus 1 is less than number of columns, then path is equal to min of path, calculate r c plus 1. And then we return the max of these two, right? Because it's the current score or path. So, okay, so return best, max of best and path. And I think that's all you need. And yeah. Oh, well, okay, that's not great. The question now is whether I'm off by 1 or is it just wrong, right? Let's take a look at RC. And I know that I haven't done the memorization yet. Don't worry, we'll get to it. But debugging 0 is at 6. So okay, let's look at some base cases, right? So 2 is going to be 6. Here, here we need the help to be 6. Oh, I didn't add the score here. I keep the minimum, but I do, but I don't take account the addition. So that this means that coming here. Okay, so I just think I didn't consider a part of it. That's all. So here it needs the answer to be at least 6. Here that means going in, the answer could be 5, right? Yeah. So I only consider the case, but I didn't add things. So okay. So we just have to. So the good part is that we just have to change this a little bit. But in what way? I just want to be careful. So this is 1. Then this path would be, yeah, so this has to be 6, so this just has to be 5, right? So okay, so the path here, and then the path, I was trying to think. Okay, the score thing, maybe I just got it confused. But so now path plus equals to, and one of these has to be true because otherwise this is true, so we don't have to worry about this being infinity. But it's equal to dungeon of RC. If it's 1 or minus this, because we want the inverse of that. And I think we do need to consider it a little bit. Oh, yeah, I don't have path. I don't have best. We do have to be a little bit careful because I think the consideration is that it cannot be negative, right? So in that, if it's negative, then we have to return a different answer. So let's do this for now, and then we'll see what the answer is. Okay, this is not great. Let's see when it's negative 24. What? Yeah. Okay. So that means that if it's 1, it gets to 30, and then I guess that makes sense in some sense. But okay, what's 1, 2? Okay, so that's 5. So that one's correct. But these other ones are the ones that we talked about where you cannot go negative. So is 1 good enough? Yeah, I guess so. So we just have to do this. Okay. Is this right? Just want to mentally think a little bit. Yeah, because this is the minimum health to make it 1, right? So okay. I hope this is right. Otherwise, then this will be awkward. But let's do this dynamic. So this is just a recursion, right? There's no memorization. There's no dynamic programming. So what do we do now is think, well, well, how do we convert this to memorization? Well, looking at R can only be between 0 to rows, right? And C can only be between 0 to columns. So that means that these are all the possible inputs to this function, right? And because of that, that means that it's gonna take all of R times C times, because that's the number of possible inputs. And for each of these inputs, we're only doing all of one operations. And it turns out I didn't need this, but that's okay. So in that sense, the complexity will be R times C, which is the number of possible inputs, and of 1, which is how much each input, how much work does each input do, and then total time is equal to O of R times C times 1, I guess, which is equal to O of R times C. And then space, well, it'll be more obvious, so I'm gonna, hold you in suspense for now. But let's implement the dynamic programming then, the memorization. So cache is equal to what is it? Let's just say 0. It doesn't really matter. Times cost plus 1 for. So this just it's very Pythonic, but it basically creates a columns plus 1 times rows plus 1 matrix. So yeah. So then, and then just to check that we've already done, then already calculated is equal to basically this. False. And we'll use it in a way that we'll see in a second. And then here, well, we still want to return this as the base case, but otherwise, well, let's see if it's cache. If calculated of R and C, then we return the cache. Otherwise, at the very end, we set the calculated result is the cached result is equal to this thing. We set the calculated is equal to true because we calculated, and then we return the cache result. And that's all there is. And going back, the space complexity is going to be O of n times m, or rows times columns, because, well, that's how many cells we have in the matrix. We have 2 of these matrices, but otherwise it's the same. So let's run it again, just to be sure. Okay, it looks okay. Let's test some base cases, or like edge cases rather. Empty array the other way, -5 from the beginning. Does it have to be at least 2? I don't know. I guess it doesn't. It's not clear. But yeah, -5 in the beginning, and then let's just 0 all the way through so that we see and then the other way where maybe the princess is have a negative and nothing else, so that we have to count the last one. That's all. Which one is that? This is just a Leetcode specific error. Maybe these are not valid inputs or something. Let's try that again first. It's either that or I just have a typo. Okay, I think I just have a typo somewhere. Oh, I missed commas. Okay, well, seems like some of the empty cases cannot be happened, so let's just remove the empty. I don't know. Okay, so that looks good. Are there more cases? I guess let's just do a couple more for funsies, and then just add. This should be all positive numbers, which should give me just 1. Okay, cool. So that looks good. Let's submit. Sweet. Okay, cool. Yeah, so that's kind of the problem for today. I think for this one, as I point out, it is very if you are trying to upsolve this and practice converting this from memorization to bottoms up dynamic programming, and I urge that you do. It's good practice. I have a video below on a link somewhere, but also keep in mind that the order matters, and that's what I said in the beginning, where you cannot go the other way, because at a certain times, because max this function, this max of path is n1, it could get into a situation where you can go in one direction with a lower number than the answer going from the other direction. So be careful about that. Or if you want to just learn about the properties of why that is, play around with that and see why that is the case. And that's like one of the best way to learn, is not only looking up good solutions, but playing around with bad solutions and trying to figure out why they're wrong. In this case, it comes up in random places for dynamic programming. But yeah, in terms of interviews, I think this is a little bit on the harder side, but still doable. So I recommend practicing it. And overall, there are a lot of things, unless you're very good at dynamic programming, and I still don't consider I am. There's a lot of things to practice on with the caching and stuff like that, and then converting it to bottoms up, and then do the space optimization. Yeah, and for competitive programming, this is probably very standard, and you really need it to be good at stuff like this, because it comes up all the time. Yeah, that's all I have for today's problem. Let me know what you think. Hit the like button, hit the subscribe button, and join the Discord channel, and I will see y'all tomorrow. Bye bye.